Hello, everyone, and welcome to Unnatural Selection, the Ethical Dimensions of Genome Editing, organized by Public Science UofT and support from the National Engineering Month, Ontario. My name is Kathy.
My name is Natalie.
And we will be your co-host today.
All right, great. So before we get started, we just want to acknowledge the land that our club operates on. So for thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit River. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work and study on this land.
Our agenda for the evening is as follows. To start, we'll give a brief introduction to public science and our club's mission. Then we will introduce our amazing panelists that we are so honored here to have accepted our invitation. Before jumping to the bulk of our today's discussion on the ethics of genome editing. So to give a bit of context to the topic that we'll be discussing, we will introduce to you the controversy surrounding the use of genome editing on 2 baby girls in China. And at 6:10 or a bit later, 6:15, we'll start a roundtable discussion until 7:25.
So as mentioned earlier, we are members of Public Science. We are a registered Canadian charity founded by scientists and engineers. Our mission is to advance STEM education across the world and create lasting solutions to poverty. We do this by running a series of programs designed to engage students and spark their interest in science through fun, hands-on, and community-relevant learning.
But just before we start, if everyone in the audience could please turn on your camera if you feel comfortable, but please keep your mics off. If you have questions or opinions you want to share with us throughout the roundtable discussion, you can pop it into the chat and one of our members will read it out for you, or you can raise your hand via the Zoom function and you'll be asked to unmute. Finally, as we are discussing a very highly controversial topic today, please remember that if you'd like to express your opinion or ask questions to our panelists, please do so in a respectful manner. And we are honored to introduce to you to our panelists. First of all, we have Professor Jennifer Mitchell. She's an associate professor at University of Toronto in the Department of Cell and System Biology, and she uses CRISPR genome engineering to study stem cells.
Next, we have Professor Kerry Bowman, who is a clinical bioethicist at UofT in family and community medicine. Dr. Bowman follows a range of bioethical issues, including ethical questions in emerging technology such as CRISPR-Cas9, cloning, and reproductive ethics.
Next, we have Professor Janelle Taylor, who is a medical anthropologist at UofT. Her research and teaching focuses on anthropological perspectives of how people dealing with illness make meaning and how the meanings make matter in the world.
And finally, we have Professor John Berkman, who is a moral theologian at Regis College, UofT. He specializes in fundamental moral theology, healthcare ethics, and theological anthropology.
So now let's prime our discussion with an introduction to the CRISPR baby controversy. So in November 2018, two girls named Lulu and Nana changed the world. They are the first humans with artificially edited genomes. The twins, now better known as the CRISPR babies, were created by a scientist named He Jiankui. The now infamous experiment was made possible by a very revolutionary genome editing tool known as CRISPR, which allows researchers to edit very specific regions of an organism's genome. This technology, albeit powerful, was previously never tested in humans. Dr. He attempted to make a specific change in the DNA of the then unborn twins in the hope of rendering the twins immune to HIV infections. The edited gene might be passed down to the twins' children if they decide to have any, and may then be passed down to their grandchildren, their great-grandchildren, and on down the generations.
This incident was a huge controversy across the globe within the scientific community, bioethicists, governments, and the public. CRISPR-Cas9 and genetic engineering raises questions like, who will be allowed access to this new technology? And how will this contribute to existing disparities within healthcare systems? And how do we incorporate any religious perspectives into the discussion around ethics? Thus, it leads us here today to have a necessary conversation with experts in various fields about the ethics of genetic engineering and the various implications that they have or would have in the future.
All right, so to start us off, I would like to invite our panelists, each of them, to give a brief introduction on their stance and view on, the uses of CRISPR in your field, if that's applicable, and what do you think about the most important ethical implications at play in this situation and with this new technology. And why don't we start with Dr. Jennifer Mitchell, and if you could give us your opinion on this issue.
Thank you for the invitation to participate in the panel today. So I'm a researcher at the University of Toronto. My lab studies fundamental biology and fundamental aspects of how our genome regulates function within our bodies and how that can go wrong in disease contexts. So from my perspective, the CRISPR tools have been a huge game changer in terms of fundamental biology and also investigating disease mechanisms in cells and model organisms. This technology, because it actually is quite straightforward to use, has been rapidly applied to almost all areas of biology and has really changed the way we do experiments. And it has allowed my lab to better understand how the human genome functions to regulate critical processes like the differentiation of nerve tissue, and to understand how that sometimes goes wrong in a disease context. So from that standpoint, this technology is incredibly useful and important and has made really important new discoveries possible. At the same time, as much as I think that this has been a really important technology for fundamental science, I personally feel that it should not be applied to the human germline. Not now, and perhaps, not even in the future. So I'm fairly conservative in my views on that. However, I do think that genome editing, this type of technology, can safely be applied to chronic diseases for modifying the genome in adult cells, so in a way that would not affect future generations, to deal with genetic diseases. And that's already, some of that technology is already making its way to the clinic. But I don't think that it is a technology that should now, and perhaps not in the near future, be applied to edit the human germline. In situations where genetic diseases, where parents are known to carry genetic diseases, the current approach of selecting the embryos that do not pass on that genetic mutation is much safer and is an effective approach for not passing on a detrimental mutation to your children. And so that's my stance on editing the human germline, that I don't think we should be doing it now and not in the near future.
Thank you so much. And Dr. Taylor, could you give us a bit of your opinion on maybe the cultural impact of such a powerful technology and your opinions on issues like that?
Yeah, thank you. First of all, thank you for organizing the event and for inviting me to take part. When we were corresponding leading up to the event, I was asked to declare my stance on CRISPR.
Yeah.
And to be honest, I don't have one. I don't have one that I don't walk around with a ready-made stance about every technology that's out there. But I do think that there are questions that I would think would be important to ask about this as any other technology. So my stance as an anthropologist, as a medical anthropologist, is basically that technology and medicine are part of social life. And so that's how we have to understand them and think about them and consider their possible ethical and social consequences. And so, for example, some questions that I would want to ask about CRISPR might include things like, how are people imagining what this technology is, how it works, and what it might help them achieve. These kind of cultural imaginings that shape what we bring to technology and what we hope to get back from it have huge consequences. And just to take a really simple example, you know, when people describe CRISPR, they talk about it as surgery, or they talk about it as hacking, or they talk about it as like editing, or they talk about it as targeted drone strikes. These are different, they're all metaphors, right? And any metaphor will highlight some things and hide other aspects of whatever it is you're trying to understand. But they can have different consequences because, for example, if we think of it as editing, well, that sounds really sort of small and safe and always positive, versus if we think of it as targeted drone strikes. So, you know, I'm interested in just the ways people understand anything like these technologies and how those understandings guide actions that we take individually and also collectively. The other thing that I would really think is important to pay attention to, most technologies are designed by someone for some specific purpose, right? But once they enter into the world, they can develop all kinds of new meanings and uses and purposes. They'll be used in all kinds of ways that the original developer may never have thought of, because that's what humans do. We're creative beings. And most medical technologies, just to kind of limit it, have at least several different possible impacts, right? Medical technologies, what we call them medical because they have at least the potential to cure something, right? There's some form of human suffering that they can alleviate, and that's the main concern, right? But many of them also have a potential for enhancement. So like when you're no longer talking about curing a disease or a problem, but just sort of making ourselves better or making our children better in some way, guided by all these ideas that we have. So there's cure, there's enhancement, and often there's also a coercive dimension that goes along with any of these technologies, that it could be used for surveillance, that it could be used for, you know, to you know, further some other kind of oppressive goal of manufacturing. I don't know, you can get into all kinds of dystopian sci-fi fantasies about what it would do, right, in that direction. But the thing to pay attention to is that these different potentialities don't play out equally, right? Often the people who will have access to the curative potential, that's one group. They may or may not be the same people who have access to the potential to use this for enhancement. And often, you know, it's people who are already oppressed and disadvantaged and marginalized who will be on the receiving end of any kind of coercive or surveillance potential that the same technology has. So once a technology lands in the social world that is very unequal, it will play out according to that, you know, those differences. And I'll just stop there. There's more to say, but I'll just stop there. Thanks.
Thank you so much for that. And we'll definitely dive more into some parts of what you brought up. And we think it's an excellent point. And but now we would like to invite Dr. Kerry Bowman to give us your opinion on this issue. And sort of, you know, if you want to follow up on some of the questions brought up by our previous two panelists, that would be great as well. But I'll give it to Dr. Kerry Bowman.
Right. Now, I don't want to bore you by talking about myself, but my career is a little strange, and I should probably just clarify what I actually do so you have some sense of where I'm coming from. Absolutely, I teach at UofT, and I am a bioethicist. I've been working in the Toronto teaching hospitals for almost 30 years, very directly, very bedside. I also do a huge amount of environmental work, and it's really at the interface of human need and environment. I'm presently working in both South America and Central Africa on those projects. So I try to be a realist. I have many ethical doubts about, you know, what lies ahead in terms of gene editing and CRISPR-Cas9. I also think it's coming, and I think market forces will drive it. And I think we can tie ourselves in knots as much as we want, and our governments can. But I think market forces will drive it. And I do think we have to figure out how to do it well. Where I think there's emerging consensus, I actually feel very, Dr. Mitchell laid it out quite clearly. My views on its use are pretty well parallel to Jennifer Mitchell's clearly stated views on the use. I've worked bedside in hospitals. I've seen what some of these single gene mutations can actually do to a person and to their family. And so I do think that is coming. But let me just look at the big picture for a moment. I was actually a little uncomfortable when I saw that the Nobel was going to CRISPR. I wasn't outraged, as maybe a few people were. I wasn't losing sleep over it. But the greatest problems in bioethics right now in the 21st century are really not about gene editing or anything like that. It's actual access to basic, unsexy health care. We're talking about high-tech stuff for maybe 15% of the world's population. And when you spend time in Africa and low-income countries all over the world, it's not just Africa, you see that very basic non-tech needs are there. All of that overlaid and underpinned by the deepening environmental crisis. So, I actually felt that the Nobel going to CRISPR was quite a diversion. In fact, it kind of surprised me in that way. As an ethicist and as a clinical ethicist, I came of age in the last millennium, makes me sound ancient, but I did. And bioethics originally focused a whole lot on let's look at a risk-benefit equation. But when you look at gene editing, CRISPR-Cas9, risk benefits are really, really hard to do. And you take a utilitarian view, here's the benefits, here's the risk. Because we can't project into the future, and this constant haunting off-target question is always there. How significant off-target risks are and what they would look like. I've never gotten a clear answer on that from anyone, and I don't criticize people. I think they don't know, and so the risk-benefit equation is very, very problematic, and I find that worrisome. Also, I think many people, maybe not all of us would agree, the last thing this world needs is one more level of social stratification between people that have had advantage. Like we're struggling enough in this world without that. And I do think that's coming. And at the risk of sounding melodramatic, I actually think gene editing is a much bigger deal than the media is making it out to be, not in terms of what it can do, but in terms of the human story. This is sort of the very, very beginning of shifting from, natural selection, evolution to something different. This is actually a turning point in the human story. It's a very small turning point and it's very subtle, but it has begun. I'm very uncomfortable with gene editing of the germline. I think it creates a lot of injustice for, an open future, as many ethicists would call it, for people that lie ahead. I think that can be very problematic. And if we rolled this back maybe 5 years, we would say, well, no one's actually going to do direct gene editing of embryos. But then, the twin babies were born in the People's Republic of China, and we all had said, oh, no one's actually going to do that. Well, it's happened. And how much don't we know? How much else is going on? So I think what I'm saying is, cautious use and therapeutic use, but I'm acutely aware that what's enhancement and what's therapeutic is a very tough line, and market forces are going to push that every way they can. And market forces is like water, it looks for any kind of place where it can move in and drip through. It's very powerful stuff, and it tends to drive Western medicine primarily. I see it in the Toronto teaching hospitals. Technology is driving medicine. And when you look at the big picture, tech solutions aren't really what we need right now. Anyway, let me leave it because I think we've got a lot of good stuff going on for a discussion. So let me stop there. And
all right. Thank you so much to Dr. Bowman. And last but not least, we would like to invite Dr. John Berkman to give us your opinion on this issue. If you want to follow up on any of the excellent points brought up, please feel free to do so.
Thank you. And first, thanks for having me as a part of this. It's a real pleasure and honor to be here. I am fully supportive of everything that my colleagues have said. My view on CRISPR is very similar to that of Dr. Mitchell, and I'm really appreciative of both the kind of cultural metaphors we use to speak about it, that Dr. Taylor has already spoken about, and also how Dr. Bowman's concern about the further kind of social stratification and the further possibilities for injustices to the least of our society. I think these are all really important concerns. What I'd like to say in kind of my few minute introduction is to actually ask what we mean when we even talk about ethics, and to ask some underlying questions. Because one of the things I've learned with my students is when I even ask them what constitutes morality, or what even constitutes an ethical question, I find that there is fundamental disagreement about even what constitutes ethics. So in order that we don't simply kind of talk past each other, I want to, in about 3 minutes, kind of give you 4 different, what I take to be ways of thinking about ethics in itself. This question of what does it mean to be ethical or to act ethically? Now, for some people, I think as Dr. Bowman has already alluded to, ethics is understood fundamentally as a cost-benefit calculus, maximizing good causes over bad consequences. Thus, any human action is morally justified if one can make a plausible case that the benefits of certain research outweigh the harms. Now, of course, taking into account benefits and harms is an important moral consideration, but by itself, it's clearly an inadequate basis, I think, for morality, as it recognizes in itself no intrinsic or inalienable good in human beings, or other creatures for that matter, that have to be respected regardless of this calculus. A second understanding, I think, of ethics that we often see, or I often hear in the classroom, is one that equates morality with the law, that is Canadian or some other civil law. If the law permits the research, well, then it must be morally okay. Again, while the law often, I think, functions as a kind of moral teacher, it clearly cannot be considered the same as morality. Otherwise, one could never challenge the morality of any law. And of course, we all know that societies almost always have certain unjust laws in them. Now, I think a third perspective will argue that human law can never adequately display what is morally good adequately. Rather, that there is some notion of morality as objective, in some way built into the fabric of the world or of human nature. Those who argue, I think, for a universal ethic do it from many different perspectives, but often speak of, say, a natural law or a moral law or a divine law, which we can recognize as human beings and which should guide us morally. A fourth perspective that I think can be related to the third sees morality as part of what it means to be a human being. And for example, that it's shared with other animals, which is to flourish according to our particular nature, to exercise our capacities and abilities as human beings, as our species. To a large extent, whether or not human beings flourish will depend on their decisions through their intentional actions. Good, virtuous human actions facilitate the human flourishing of both individuals and others, and we should think of wrong actions as those that obstruct human flourishing of those individuals or of others. Morality is fundamentally about my choices and my intentional actions. And thus being moral consists in acting according to, say, what are classical virtues, like acting justly or faithfully or lovingly or temperately. And in so way that becomes a part of our character. So I think when we're thinking about these ethical questions, we might kind of want to ask which of those kind of categories of ethical argumentation are coming to the fore, even in the questions we ask. Now, I also want to affirm what Dr. Taylor has said in asking what are our underlying metaphors for thinking about gene editing, or what are the particular attitudes we bring? What are our views that we tacitly perhaps hold about how we see human life and the life of other living creatures on the planet? Now, for much of the modern period, the view has been that all of nature should be in the service of any and all human desires, and thus the project of modernity of conquering or revealing the secrets of nature, which has more or less been our Western project since Descartes and Francis Bacon. But as a result of that attitude, we've come to the ecological crisis that we now find ourselves in. So I take it as a given that our moral perspective should not simply be that any and all human desires should be catered to, although we are, of course, all tempted to think in that way at times. So what is our attitude towards our lives? For example, if we fundamentally see our lives and those of our children as gifts given to us, and we see our lives as fundamentally good, we hopefully will not inordinately grasp at new technologies without adequate reflection. On the other hand, if we think that the world gives us no guidance for action, that evolution is, for example, meaningless, then we may well think that it's our job as human beings to fix things and to bring about progress and growth through manipulating the world. I think there's one attitude that we might call the myth of progress. The Nobel Prize winner in 1946 for genetics was Hermann Muller. And he argued that what we should be concerned with is planned genetic improvement to provide the opportunity to guide human evolution to make unlimited progress in the genetic constitution of man, to match and reinforce his cultural progress, and to reciprocally be enforced by it in never-ending succession. And of course, he thought about this as going through a certain kind of selective breeding and positive eugenics, etc. Now, interestingly, originally, his models for what we should be modeling these future human beings on were Karl Marx and Lenin. However, though at some point he later got unhappy with communism and he changed his exemplars for this ideal of improving human beings to Abraham Lincoln and Louis Pasteur. Now, the point here is not the particular figures which he happened to choose in his day, but to recognize that everyone who wants to genetically improve humanity will always want to improve it with some moral ideal in mind. And who should these ideal exemplars be? What do we want to see humanity look like if we want to improve it in these kinds of ways? Should it be saints like St. Francis of Assisi or Mother Teresa, or admirable political leaders, whether our admirable political leader is, say, Martin Luther King, or Nelson Mandela, or perhaps Donald Trump, or scientists like Louis Pasteur, or perhaps Hermann Muller himself? What I hope to bring to discussion is to have us recognize and reflect on what are our goals underlying our thinking about gene editing? What do we see as legitimate and illegitimate purposes of gene editing? And can we hope to agree on them? And if we disagree, is that a reason to be very careful in terms of what our country ought to approve in terms of allowing the use of the technology? Thanks.
Okay, great. Thank you so much, Dr. Berkman. So to start us off with our first question, I just wanted to address this question to everybody. Based on what has everybody been saying around human identity and progress and how our society would look like, I just wanted to ask, how do you think that the notion that humans can become our own creators impacts human identity? And maybe I'll just start off with Dr. Bowman.
What a question. Yeah, there's a whole movement out there of people that believe that, the transhumanist movement, that we've had a dog-eat-dog struggle in terms of our own evolution. We came close to going extinct as a species, which we did at one point. We're lucky we're here. We now have the opportunities that are emerging. We need to take control of this situation. We need to use tech as much as we possibly can and become the creators. And I don't know what percentage of the population they will be, but certainly there is that thinking out there. I'd rather look to what can we, if we're looking and we're seeing suffering, which certainly we are with some kinds of long-term and lifelong illnesses, I think that's a very reasonable place to be intervening with what we can do. And it's sounding a bit idealistic already, but looking at the interventions we have, how can we use these to reduce suffering? and illness, you know, and that's a tough one because that's going to drift into different people's conception of what's an illness and what's a disability and what's not. But I do think, you know, I've seen what some of these nasty single gene mutations can do. And I think that's a very reasonable place to start. But when I say start, it already implies that we're going to just keep going. But I do think that's where we could go. The transhumanist kind of thinking that I've described, it's very science fiction. It's not where I'm at. I don't think we have to design ourselves. I think we have to go back to really what Dr. Berkman is saying, you know, what kind of a society do we want to be and what are our values? Those are the questions to ask. I'll leave it there.
Okay, great, thank you. I wanted to also ask Dr. Taylor if you had an opinion about how like humans can are creating this new society with this new technology and how we impact human identity with this new technology.
Yeah, so one of the courses that I teach is a freshman seminar called Speculative Fiction and Social Reality. And we're reading science fiction and thinking about how it both reflects the world that it comes out of and has impacts in the world. And it's really interesting because I think with something like CRISPR especially, but also with many other technologies, you can't really separate out the hype and the science fiction dimension from the technology itself, because you know these stories are so key to how the hopes that motivate the development of the technology, as well as the fears that then crop up around it. And I'm thinking about the kind of quintessential story of humans being their own creators, or humans creating humans, sort of in a way that bypasses what we might think of as natural means, which is Frankenstein, right? Frankenstein creating the monster. And it's, if all you know about the Frankenstein story is some vague memory of the movie, I'd really encourage anyone to go back and read the 1818 book, because it's really rich. And it's really rich partly because it shifts perspective. We get so many different perspectives on the story. First, we hear from a guy who's piloting a boat, who's on a boat headed to the Arctic. And anyway, I won't go into all the details, but there's like many, many different stories we get. And eventually we get the story from the perspective of the monster, right? The being that Dr. Frankenstein has created. And then the whole meaning of the story shifts, right? And I think that this shifting of perspectives is really important for how the story sort of gets us to think in a complex, rich way about what it means to kind of create human life, or to have that ambition of creating human life. And just to cut to the chase, one of the main lessons that I take from reading Frankenstein, what it has to offer us for thinking about these questions about science and the implications of creating people, is that most of what was wrong with Victor Frankenstein's act in trying to create a human being had to do with his hubris, had to do with his lack of care for the thing he created. Like, he created this monster and then just ran away and kind of like abandoned it and hoped that nothing bad would happen. Now, of course it did. All kinds of bad things happen. You hear echoes of this in the way that people are, talk about CRISPR. Well, we're gonna just edit these mosquitoes and then the whole species, and then nothing bad will happen. Well, maybe, but I think there's like a responsibility to care for the creation. And there's another key dimension of the Frankenstein story, is that Victor Frankenstein did all this in secret and alone, and without any kind of input, oversight, communication from his family, his broader community, the community of science. He wasn't properly educated in even the sciences he was trying to practice. So really the question is, what kinds of not even just discussion and inclusion of perspectives, but what kind of governance, what kind of oversight, what kind of social organization of science do we want to have, and do we need to have in order to have ethical outcomes for something like CRISPR?
Thank you so much. I see Dr. Mitchell has something to add also. If you could go ahead, Dr. Mitchell.
Yeah, so just, I mean, coming back to this idea of design, should we design better humans? Anybody who tells you that they know how to do that is sorely mistaken. I mean, people who understand as much as possible about how our genome works haven't the faintest clue how to make anybody better right now. Aside from, for example, correcting very simple single gene mutations where it's very clear what's causing a disease state, those are some things we have a pretty good handle on. But, you know, for example, because, you know, we started with this CRISPR babies example, that the desire to modify that gene didn't come from out of nowhere. So there's actually, I don't know if everybody's aware of this, there's a clinical trial that's ongoing to introduce a specific mutation into that gene that is naturally occurring in the human population and has been shown in at least a few patients to allow patients to clear an infection with HIV. So there's currently a clinical trial to edit, not the germline, but to edit T cells even of patients that have HIV to mutate that CCR5 gene so that HIV cannot gain entry into immune cells. And even in that trial, it's not the hematopoietic stem cells that are being altered, it's more mature cells so that eventually the patients will recover their functioning copy of that gene, because that gene is actually important for fighting other infections. So this individual decided to try to mutate an important immunity gene in, you know, unborn children to potentially help with, you know, the rare possibility of one infection, but at the same time may have caused them to be more susceptible to other infections. And so I just bring that up to say that, you know, nobody actually knows how to do that right now. You know, we have ideas of how to fix very specific problems that are, you know, clearly malfunctioning proteins because of mutations that cause specific diseases. So we could theoretically do that. But in terms of enhancement, you know, we don't really know how to do that properly. And so it's, you know, it's Wild West territory, or it's like asking somebody to build your house who doesn't even know how to hammer a nail. Like it's pretty out there right now.
Okay, thank you. Thank you for that insight. We also, and then I saw that Dr. Berkman had his hand up earlier. So if you wanted to add your insight to the question as well.
Well, I obviously have to get in on this one because you asked a pretty clearly theological question. The very notion of ourselves as either creatures or creators is so clearly a theological reference, right? We're creatures. When we speak of being creatures, we're talking about our relationship with God, the creator. And thus, this is a really interesting metaphor because clearly the relationship between a creator and a creature is an unequal relationship. What humans create, we do not have an equal relationship. They are things that we create through our techniques, through our abilities. But then the language we use about having our own children has never been create, but to beget, because the children, they're not our creatures, they are our children, they are of an equal status with us. And we clearly are not of an equal status with those things that we create. And we see that in Mary Shelley's work, we see that in Pinocchio, or all kinds of examples of stories. And so in a sense, this question of becoming our own creators is becoming in a very strange relationship with ourselves or our offspring. can we really see our children as our children if they are products of our technique, products or creations of us, rather than begotten by us? And so I think this metaphor of creature and creator is very significant. And we have to recognize that the creator and the creature can never be on an equal footing with each other. And so just to reflect, I think, on that metaphor is, I think, a very important one.
Thank you so much for all the great insights that stem from this one question. And yeah, I feel very much enlightened about so many great perspectives. And now I would like to actually go into one of the questions that were raised by one of our audience members. And this is a question from Asher. And they want to know, given the panelists' consensus on human germline editing, I'm curious what the panelists think about CRISPR editing of germlines of non-human species that might get put back into the wild. For example, mosquitoes for malaria control, as biological control of invasive species that currently cause ecological damage, or agricultural animal plans to improve food resources and nutrition. And I would like to direct it maybe to Dr. Mitchell, if you could sort of comment on if you have any thoughts on that that aspect of CRISPR as it's used in research and things like that, or Dr. Bowman, either one of you.
I mean, I can just quickly say that I don't have a lot of expertise in that area in terms of for example, gene drive and in pests like mosquitoes. But again, our environment is incredibly complex and incredibly complicated. And, again, if you do look to literature, there are countless examples where you tinker with something and it has effects that you did not expect, and it's not usually good. So, I would exercise extreme caution, and I'm highly skeptical that we can 100% say that we're not going to cause harm that way. So again, I'm pretty conservative on that point as well, that, it would have to be 100% clear that we weren't going to cause more harm than good. And it's not really my area of expertise, but yeah, that's my view.
Thank you. And I saw that Dr. Taylor has raised her hands. And could you lend us your opinions on that?
I think it was me. No?
Oh.
Dr. Taylor, did you?
I did raise my hand, but I would like to hear from you first.
Oh,
Yeah.
you sure?
Oh.
Okay. But I'm a windbag. You'll be
yes.
sorry.
Dr. Bowman, please. Yes.
We barely understand ecosystems. Barely. And they're crashing. We are losing biodiversity. We are wiping species off the face of the earth on a daily basis. So we barely understand what we're doing. And, gene drive and mosquitoes and these types of things, we're dealing with a lot of the rise in vector-borne diseases. Zoonotic diseases are very, very much tied to massive assault on the environment. And we're looking for a tech solution to that. This very pandemic that we're immersed in now is very much related to the loss of tropical forests. It's a long equation. I'm not going to, it would be a separate presentation if we were to go there. So I think that could be very damaging. I really don't think we understand the big picture. And we're trying to fix something without getting to the core of what is causing this. But look, is it going ahead? It's going ahead in Key West, Florida. It's going ahead in regions of Brazil. When I say it, gene drive related to mosquitoes. So these kinds of pilots are going ahead, but I think it's very dangerous. Gene editing of other species and for species survival. I mean, when you look at the Asian macaques, which are of course monkeys, and the gene editing of them, they've been introducing features like autism. And in terms of suffering, you take a sentient social species like a macaque. Remember, obviously they're nonverbal. So when I say social, it's not social as we humans would, it's nonverbal social. And then you impair their social functioning. I mean, how far do you want to go with torturous awful stuff. And, you know, it's because they're not human that we feel like we can do all these incredible things to them. You know, I think one of the things where CRISPR may really drive forward, when I said market forces will drive it, you might have been thinking, but, you know, the government of Canada is certainly going to legislate this and that. I actually was thinking a lot about environment. And, you know, there's life forces like algae and things like this. So there's a lot coming. And I worry that the surveillance on CRISPR in relation to the environment and other forms of life will be much, much more slight than it would be for humans. Dr. Taylor, sorry, I cut you off. Go ahead.
Well, I'm not a biological scientist, and I'm obviously not an expert in this, but we share a lot of our genome with all kinds of species that are much more distant from us than chimpanzees. I mean, we share lots of our genome with bacteria and yeast and all kinds of things. And I think it's just we are animals among other things, and it's a mistake to overlook that. And I think, you know, the point I was trying to make before about people having ideas that motivate these development of technologies, you have an idea about what you want to accomplish and the problem you want to solve and how you're going to do it. Once it lands in the world, it has all kinds of consequences that you never would have anticipated. And those need to be attended to really carefully, even just to understand what is the impact of anything that we do, right? We need to be paying close attention to those things. And the more powerful the technology, the more imperative it is to be really, really humble, I think, in terms of unleashing these things on the world, because those unintended consequences will come back to us, and they do come back to us in terms of, you know, creating antibiotic resistance through overuse of antibiotics, or creating all kinds of environmental consequences that come right back to our own health and the very problems we're trying to solve.
Thank you. That was really insightful. So our next question is actually one from the chat from Patricia, and she's just wondering, what about ethics in culture DIY bio, or like do-it-yourself biohackers? Do you think there's a need to regulate cultural aspects of genetic editing or like DIY bio? So I want to ask this to Jennifer Mitchell, Dr. Mitchell.
Somebody else first, please.
Okay, yeah, sure. If anybody else has anything else to add. Dr. Bowman, if you would like to add anything. You're muted, sorry.
Why don't we ask Dr. Berkman first, then I'll go second. How's that? Is that okay?
Okay, yeah, that's okay.
Sure. I think there's a really massive under-recognition of the power of this technology and the potential harm that can come about through it. I mean, we just lived for the last year and a half through a pandemic, and we don't definitively know the origin of the virus, whether it simply came from nature or whether it came out of some laboratory and escaped, et cetera, et cetera. The potential for new variants, which are very easy to produce through CRISPR, we have no idea of the potential damage. When it comes to viruses, we may think of COVID-19, even though it killed millions of people, as a relatively weak virus compared to some others that could have been far deadlier. And these are the kinds of things that I think can could possibly be manufactured by your average teenage biohacker if it's really a matter of changing one or two genes. So I can't say I know the exact genetic makeup or variant of this virus from other flu viruses or related viruses, but governments of the world don't seem to have a recognition of the potential power and disastrous powers of such creation of viruses or other organisms. I mean, everybody recognizes that nuclear weapons and nuclear bombs are extraordinarily dangerous for the future of the planet. But I think one has to be aware of these potential viruses that could be easily as damaging as nuclear weapons. And so that's a quick way to say, yes, I think there's good reasons to regulate certain kinds of biohacking. How you would go about doing it, I have no idea.
Dr. Bowman, yeah.
Yeah. So I'm certainly not going to be supporting biohacking, but let's just talk about the, the social genesis of it. When you actually talk to biohackers, which I have done quite extensively, actually, they don't all call themselves biohackers, but they're DIYs, do-it-yourselfers. What they say is, science is conservative. It's extremely slow-moving. It's not particularly democratic. And the priorities of science are usually really very much out of alignment with the priorities of the people in general. And it's increasingly swayed by pharmaceuticals and profit-driven industry. So the rationale for biohacking is, and I'm not trying to glorify it here. That's not where I'm going. But it's not going to go away. I mean, this is a significant social movement. And, CRISPR-Cas9, to my best understanding, and we'll soon hear from Dr. Mitchell, is not incredibly expensive. And you don't need a $3 million lab to do it in. You can do it in many other ways. And, when you look at the kind of social movements that you see in California and things like this, these are very powerful movements. If you spend time in California and you see, just flush with tech money, how powerful this kind of biohacking movement is. It really is a substantial social movement. I don't think it's going to go away. It has no checks and balances. I don't know how you're going to be able to monitor it. My mind is still open. I think some good may come out of it, but it could be absolutely catastrophic. But it's an increasing movement, and people doing it, there's massive gaps in terms of their scientific training, massive. They do tend to be clever, but they don't have all the solid building blocks for doing these things. It's not going to go away. And I think as the 21st century progresses and the environmental crisis deepens, I think biohackers may take things into their own hands if they don't like the way things are going, and they probably won't.
Thank you so much for your insights. And does anyone else have any insights to share on the topic of biohacking? Dr. Mitchell, maybe? Did you have something to say?
I mean, I just think it's incredibly dangerous, so there were a few early successes with gene therapy. For example, for severe combined immunodeficiency disorder, that's the boy in a bubble syndrome. So, there was some early success with that kind of technology that actually delivered a functional gene and helped children with that disorder to have a more functional immune system so they didn't have to live in a bubble anymore. But a large enough percentage of those children developed cancer as a result of that treatment. And so because that happened, we basically stopped that kind of approach because it was, causing harm, right? And so I think that the most likely outcome of some of this biohacking is that people are going to give themselves cancer. That's the most likely outcome. And so I just think it's incredibly dangerous. And, people do really need to be careful, and they do need to respect, that this technology can modify their genome. And most modifications to the genome cause trouble rather than anything beneficial. So, yeah.
Thank you so much. And Dr. Taylor, I saw your hands were raised.
Yeah, I don't actually have a lot of knowledge about biohacking, but the idea that they are going to sort of take matters in their own hands because they feel excluded from science, think that science doesn't care about their issues and doesn't prioritize things that matter to them, that suggests to me that ultimately there's a big picture question about how we organize science socially, right? Like, how can we actually include people in such a way that they're not going to feel like they're going to go out and go rogue on themselves? Because, if the hope of controlling, regulating any of these things is to have active oversight of science by scientists and by the public and their elected representatives and all these good things, science itself needs to be as inclusive as possible to bring people in.
Thank you so much. And on that, I would like to sort of ask a follow-up question, as I have noticed from our panelists' opinions on, too much is unknown, and the idea that if we are to judge on, the risk and benefits of it, is it reasonable to expect that there is some point where we can sort of say that we have known enough to declare if the benefit outweigh the risk, and if we should do it, and who should have a say to sort of include that that voicing our scientific discovery, and sort of include their voice, have their voice heard. So I would sort of to rephrase my question, I guess, is to what extent do we need to know about this technology, and how much does it have to be developed for us to sort of make a judgment, and who should make that judgment on whether or not we should put restrictions, or to say, let's go for it. And I'll just give a few moments for you to think about that. And if anyone has an opinion, please, let us know. And yeah, Dr. Bowman.
Mm-hmm. There's many ways of looking at ethics, and risk-benefit equations, we could call that utilitarian. I don't think they're ever going to be wonderful when it comes to this type of things, because risks are just simply, they can also be so far off, so far into the future, and often quite unknown. Who should be involved in the decisions? Well, society, but that's a very simplistic answer. Society doesn't have one opinion. And we're living in an extremely complex, pluralistic, and morally pluralistic society. So it is not going to be easy. We need broad discussion on these types of things. And when you get hit with a crisis like the pandemic, I was doing a lit review in advance of this seminar today, the one we're on right now on CRISPR, and boy, have things fallen off during pandemic times, right? The media is not that interested. I shouldn't say they're not interested, but pandemic dominates. So we need a huge amount of discourse on this type of thing, but how we're actually going to move forward, I don't know. And I think where we might get legislation on, can we edit human embryos? Can we not? We're developing consensus on that. But I repeat myself when I say when we start editing algae and mosquitoes and things like that, I suspect we're not going to have a lot of legislation. So I don't know. Let's see what my panelists think.
Thank you, Dr. Bowman. And Dr. Berkman, I saw that you have your hand raised.
Yeah, it's interesting. The issue that originated modern, what's called bioethics in the 1960s and 70s, was the question of experimentation on human subjects and the abuses that had been going on in various places, Tuskegee and other places. And one of the things that often becomes very clear is that historically, and it continues, that experimentation on human subjects up until a real strong regulation relatively recently, and even when you have this regulation, typically goes on the underclass of a society. Your blood donors, the people who agree to do experiments and get paid to participate in them, they do it because they need the money. My roommate in graduate school was this poor guy from Scotland, and he was constantly going over to the medical center to get experimented on because he needed the cash. I mean, now he's a full professor and head of department at Yale. He would no longer do that. But if you look at the kinds of people who participate in these, it's because they need the money, and they take, undergo these dangers of being certain kinds of guinea pigs. And there's a certain fundamental injustice in that. And I think in terms of people claiming that it's safe enough to be undergone, such experiments should be willing to do it on themselves first, because hopefully then they're really going to take seriously the potential risks and benefits. And or if we really think this is truly good for our society and it's a social good, then there should be a kind of conscription for research subjects. Everybody from the prime minister on down should have an equal chance of participating in these experiments. And if we really thought that everybody in the society could contribute by being a subject of experiment, I think we would have very strong controls in terms of risks of experimentation. When we only experiment on prisoners, on the poor, on children, et cetera, the controls over them, I think, are inherently less strong. But if this is really about the common good, then I think everybody should be willing to participate in such experiments. And if the powerful had to do so, then the controls, I think, would be very good. So one of those two, either on yourself or make it so that everybody in society has to be willing to be the subject of such experiments.
Thank you. And Dr. Taylor?
Well, I just want to second the point that that Dr. Berkman was making, that the risks and the benefits get allocated often to very different groups of people, in line with all the other inequalities that we have, right? But I also wanted to just disagree a little bit that we don't experiment on ourselves or society, because we do. We just don't call it that, right? I mean, we have massive uncontrolled, unthought through experiments going on around all kinds of products and medications and things that are being consumed, used on a vast scale without a lot of attention to what the possible implications may be, which isn't to justify it, but just to say, yeah, there's a lot going on out there that isn't carefully thought through. And I think we could do with a lot broader discussion involving more people. I mean, I guess I want to just really second Dr. Bowman's point that we need a lot more attention, a lot more discussion, a lot more discourse around all these things.
Thank you so much. We have a question from the audience, actually, to sort of follow up on that. And it's from Neil and Eileen, and they are wondering, do any of you think that it should be this technology, to advocate for the outlawing of this technology is justified? And if you anticipate that this will be eventually outlawed in some countries or in all countries, will come to a consensus, and could that be considered to be anti-progress, and your opinions on that? Okay, Dr. Mitchell.
I put something in the chat already, but
yeah.
So, I think a good parallel to considering should we intentionally modify the human germline is cloning. We as a society decided that was not allowed, that it's not legal. So in my opinion, this is a sort of similar to that, that you can't, it's very hard to make a case for it being necessary. And so, I think that's the best sort of comparison.
Thanks. Dr. Bowman? Sorry, Dr. Bowman, you're muted.
We can legislate some things, but what's going to go on in Burkina Faso, and people can set up labs anywhere in the world. So I think things will, even cloning. I'm not pro cloning, but as a monozygotic twin, how weird is cloning? Like, is that really a freak show? I'm not supporting it, but one could argue it's already occurring within nature. So there's always those things to consider. I don't think we're going to be able to stop a lot of this. And, there may be stuff going on all over the world that we don't even know about now. And again, what forms of life are we looking at? I think our greatest chance for legislation would be, the human element. But if we look to reproductive ethics, which is a slightly different story, Canada is absolutely stuck. We've got the Act, the Human Reproductive Act of 2004. It's shockingly outdated. And I work in reproductive clinics. It's almost useless. It's so outdated. And, we're doing the Canadian thing. We're sitting on the fence. We're waiting to see what other countries do. We're hum, and so we may do a lot more of that, I think, in the future. And this one's going to be tougher than the Reproductive Act, I think.
Thank you so much. I'll give it to Dr. Berkman.
I think, again, the analogy with nuclear weapons is apt if this technology can be equally dangerous. Sure, countries can be doing it, but the world still spends a lot of effort trying to control or limit access to the manufacture of nuclear weapons because it considers the more widespread proliferation of them to be extremely dangerous for the future of the planet. So yeah, I believe that there's no doubt that various people, countries, etc., will seek to be engaging in this. But if it in fact is as potentially dangerous as the proliferation of nuclear weapons, I take it that's a good analogy for reasons why there ought to be certain controls over it, if we believe that it can be that dangerous. And maybe I'd like to turn to Dr. Mitchell as an expert on this technology as to whether she thinks I'm correct in terms of the dangers, potential dangers of it.
So yeah, I think the potential dangers are huge in terms of editing the germline, partly because 98% of our DNA does not code for genes, and we actually don't know what most of it does. That is my area of expertise. I study that non-coding genome and how it turns genes on and off and how it regulates function. And we know very, 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 very little. So, what is a one base pair change going to make in that 98%? We don't know. In some cases, probably nothing, but in other cases, maybe a very serious problem, So I do think that this technology is not even close to being ready to apply in a situation where you're going to change the genetic makeup of a healthy individual. It's just not ready. At the same time, there are very horrible single mutation genetic diseases. For example, progeria that causes the early aging of children starting from 2 years of age, and they usually die at around 14 years of age, with horrible complications from this disease. If we can deliver a, editing, if we can actually edit that mutation and fix it in enough of their cells, we could massively increase the quality of life for those children. And I think that's worth it. That is 100% worth it because, if there's not a lot to lose there, right? They have a short life expectancy. There's a lot of complications. And there's a lot of potential to do good in that situation. And so I do think we should apply it in those cases. And in those cases, I think the potential risk is much smaller than the potential benefit. But yeah, I think we are massively overestimating our understanding of the human genome to even think that we should start to change things that aren't that kind of very specific mutation that we really understand what's going on.
Thank you so much. Just feeding off what has just been said about not knowing or having very little research concerning surrounding diseases. So that many drugs that we use to treat difficult diseases such as rheumatoid arthritis are being used without fully understanding the mechanisms and the potential long-term effects based on the fact that it currently provides therapeutic benefit and because there are no other treatments available. So given that we do not have any reliable therapeutics to treat genetic diseases, do you think that it would be worth the risk to use this technology and provide effective but potentially risky treatment? There's anybody? Yeah, sure. Dr. Taylor, if you have anything to add.
I think here again, you get into a question where it's not always easy to separate treatment from prevention, from enhancement, right? If, for example, if you're talking about discovering a genetically linked condition and then intervening in the individual who's inherited that to alter their their genes, maybe even their germline, to kind of really intervene with CRISPR in that way, then you get into lots of tricky things, because many of these conditions, so just it's not hypothetical. There is a familial variant of ALS that happens to run in my family. Okay, so my aunt, my uncle, my grandmother, and other people farther back all died of this. I don't know if I have it. I mean, there's a test. I'm not going to take it because, to be honest, they all lived to about 60 before they developed this condition. And personally, I'm not willing to say that that the 60 years of life they may have had before this condition manifested itself means nothing when weighed against the potential to eliminate that disease and its very real suffering that comes with it. So, I mean, I think like the idea that we would be able to just eliminate these problems still gets you into really thorny questions about how to value a human life, how to weigh potential futures against the suffering that might be alleviated. And it reminds me of what the disability scholar Adrienne Ash, who herself was blind, a philosopher and disability sort of scholar, she talked about the sin of synecdoche. And synecdoche is like this abstract, is this grammatical term for, how a metaphor describes one thing in terms of another. Synecdoche is when you describe something in terms of its part, one part of it. And she was trying to make the point that if you judge a whole person in terms of the one trait, whether that's a genetic susceptibility, a disability that's acquired, there can be one trait, and that's the only thing that you can assess the value of that life. You are radically foreclosing all the other potentials that anybody has, and all the other talents and aspirations and experiences that people have. So I guess I would just want to caution once again against the fantasy that this is going to be a simple fix, even if it's just about solving a genetic disease. Yeah, and maybe with that, I'll just pass it back to Dr. Mitchell, who knows much more.
Just to clarify, I was talking about somatic modification, so not changing the germline, even in those disease situations. So to try to help the individual as a patient who has very debilitating disease, in that case, I think it's worth it, but still not modifying the germline. That's just to clarify.
I see. Sorry, I just have a sort of follow-up question to that. So I've heard I think a consensus from our panel saying that the germline is sort of the threshold where we draw the line. And is there any, particular, concerns that we should raise up about germline editing specifically? Because I think that was one of the reasons why the CRISPR baby were such a controversy. And like the impacts it might have on the human gene pool and what we do to our children, for example. And if any of you have any additional thoughts that you would like to add on that.
I guess this though is the question, like, why is that a no-go? Like,
Yeah.
Mhm.
I mean, so, I mean, that is the scenario where the patient can't give consent, right? That's one reason, I think. And also where if any unexpected harm does come from it, then it's harder to get ourselves out of that problem, right? If what you're doing is making somatic changes and not altering the germline, those changes don't get passed on to future generations. If you're changing the germline, then they do. And so it's a very, very different thing, right?
Thank you. And I saw Dr. Berkman.
Yeah, I think there's a certain point where we really do not want to take responsibility for certain kinds of things. I mean, just following up what, I mean, Dr. Taylor was saying about the sin of synecdoche. Remember, when those two baby girls, if they grow up and they find out that because of this gene modification, they've got a deadly cancer or all kinds of other disabilities, it's no longer, well, this is providence or this was an act of God and nobody tried to act in this way, but this is my lot in life. But when you know that a human person intervened and through their specific intervention, in a sense, gave you these characteristics that you would not otherwise have had, that's, you know, that seems to be much more troubling. I mean, you want to talk about future lawsuits. I mean, of a wrong that this scientist did to you. I mean, geez, some people even sue their parents just for having them born. I mean, that seems to be insane. But now you're starting to get into real sense of real harm that you do to other people that they couldn't, you know, consent to. And so there really is very good reasons for wanting to say we need to leave things alone, because we ultimately don't want to be and shouldn't be responsible for the consequences of certain things that we could do. And if we have a certain humility, we should not want that responsibility upon ourselves.
Thank you so much. And with that, unfortunately, we are running out of time, and I have seen so many great questions in the chat, but unfortunately, we cannot take all of them up. And I would like to say a big thank you to all of our panelists and to everyone that have come to our event. Thank you so much. And now I will give it to Natalie for several points that we would like for you to know. And I'll give it to Natalie.
Thank you again to everybody who participated, and of course to our panelists. We hope that you were able to learn a lot about the different perspectives and about surrounding the ethics of genetic enhancement. This event was not possible without the funding provided by National Engineering Month Ontario and the support of our panelists and our Pueblo Science team. We just wanted to remind all of our attendees to please fill out the poll that we have on Zoom and our post-event survey that will be open right now. And in addition, Pueblo Science is looking for to recruit more volunteers to create TikTok content and video tutorials for an ebook of our science experiments. If you are interested, please sign up via our website, which will be posted in the chat down below. And so thank you everybody for participating, and we hope that you have a great rest of your evening.
Thank you so much. Thank you to everyone. Thank you for your participation.
Thanks.
Thank you. I hope you have learned something new.
I definitely did.
I definitely did.
Yeah.
Thank you so much, especially to our panelists. Thank you for coming. I've learned so much from you.
Thank you for the invitation. Bye,
Yes,
everybody.
thank you very much for the invitation. I learned a lot
Bye,
too.
everybody. Thank you. Bye.